Hi, my name is Wonjun, and in this video, I'm going to run my program and show the ER system in action. And here's my main and three other header file and README. Um, in the terminal, by typing this, I'm going to run the program, going to compile it, and to run the code. This. And here, as you can see, I have output. So here I have a total of 7 other patients, and under their conditions, I have a list of their patients need to be treated. Here's the priority numbers and their symptoms. So the calculation of priority is based on their triage, wait time, and the age boost. So each triage, which means how critical their condition is. So 5 is the max, which is very critical, and 1 is the minimum. Wait time is obviously should be there to give a little bit of a boost. So whoever waited longer, they get the high priority. And at the same time, they have another age boost who's less than or equal to 10 years old or greater than or equal to 70 years old gets the age boost of 10 points. So here's a Richard whose age is 10, but it's triage of 8, wait time is 4. So he get the age boost of 10 and wait time of 1. So in sum of 500 times 11 is 511. So Richard will be treated first. So here you could see Richard's now in the room, see a doctor, and after Richard, as you can see, Irene, Hugh, Leaf, so on is on the list. So here's the queue after treating one patient, which is the Richard. And while Richard was being treated, there's a new patient, Jeremy, has suddenly came in with the stroke system, stroke symptoms. His age of 72, triage 5, and since he just came in, he doesn't get any weight boost. But because his age is set or older than 70, he gets the another age boost of 10 and triage 5, which is 510. So even though Irene's supposed to be a next after Richard, but Jeremy take over the original Irene's place. And here's the hip structure. Of course, Jeremy is the highest, so he'll be up on the hip, and will be on the left side of the hip, and Irene will be on the right side of the hip. And under the leaf, we will be having Dave and John. And under the Irene, we'll be have Jivork and Hugh. So after Richard, there'll be 4 other patients will be treated at the same time. Here you can see will be Jeremy, Irene, Hugh, and Leaf. So here's other 4 will so 4 patients will be treated, and after Leaf, here's other remaining 3 patients need to be treated. Sorry for John, who've been waiting 50 minutes, but still at the bottom of the list because his triage is not that critical and he's not in the age of getting the age boost. So yeah, here is the remaining patient list. And from here, by removing the stashes, and I'm going to save again. And I'm going to compile and the file again. There's a little bit of interesting point where you'll see here Leaf actually got his condition, it got worsened while waiting. So he was actually on P3, but because his condition got worsened, his strategies goes up for one above. So here Leaf's supposed to be at fourth, tri-age of 4, which was 404 points. So he was placed at the fourth place. But because he got the one tri-age up and got another boost, while he was at the 4, he's now at the second after Jeremy. So here, now I have a different order of trading, and then the remainder will be same. So here's a little demonstration um, of one priority update, condition worsen. Um, yeah, that's that's it for demonstration. And while doing this project, the hardest part was designing a balanced priority formula that reflected real world ER logic. As far as triage dominated all other factors like this triage 5, 4, 3, 2. And I fixed this by adding small boosts for wait time and the age, making the system more realistic. Um, the aha moment is I realized that hip structure naturally fits this kind of problem because it always keeps the most urgent patient at the top. It was great discovery that I can maintain real-time updates. In this case, Jeremy or previously Richard. Uh, yeah, I could maintain real-time updates efficiently using a simple Hipify operations. Um, Using a Hip turned out to be the perfect choice for this project because it always keeps the highest priority patient accessible instantly while allowing insertions and updates to happen efficiently in log n time. Um, the heap automatically reorders itself with minimum computation, which is the constantly changing condition of an ER where new patients arrive. Like here, Jeremy, excuse me, and priority shifts. Like um, Live here whose condition got worsened, so he got a little boost of triage with the new order. From this project, I learned how to build a heap completely from scratch using vectors, how algorithm design directly affects a real world system. So here is the factor. And how to simulate dynamic priority updates efficiently. Overall, it helped me see how abstract data structure concepts like heap actually support real life decision making, such as managing patient urgency in an ER room, which is pretty familiar with me, who's been working at the hospital for a couple of years. Yeah. And that's it. Thank you for watching this video and hope you enjoyed it.